Hello everyone, welcome to Automation Community. In this session, we are going to see about BCMP instruction in Omron PLC. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates and videos. So what is this BCMP? So it comes under the comparator instruction. Okay. So BCMP is block compare. So before we have seen instructions like comparing two values, right? That may be a greater than or less than, like that. Now we are going to compare two blocks. Two complete 16-bit we are going to compare. Okay. So I'm going to get help from the manual. So this is the instruction block for BCMP, block compare. Okay. So in this we have three things. First one is source data. So which data you want to compare? That data you have to put it in source. The second one is first word of block. So this is the block we are going to take as a reference, and the result have to be stored in R, that is result word. So the first one is source data. This is first block of word, the first word of block, and the last one is result word. So there are three content in block compare instruction. Let's see more about it. Now yes is the source data, as I have told you already. This is the source data. This is the one we are going to compare with B. B is what? B is the block. See, the first block, the first word of block. So the B is having some ranges of values. So I'll explain you in the example in a better way. And R, which is the result storage place. So now what we are going to do? For example, you are going to have one value in the source and you are going to have some value in B. Okay. So now this B, what it will do? It will compare the value which is in S within the range B and B plus 1. What is B plus 1? For example, if I am declaring B as 200, 200 and 201, D200 and D201. So the value which is in source is in range of B and B plus 1. Then it will return 1, else it will be 0. Okay. So now let's imagine B is 200. The address I am telling. Okay, D200. And B plus 1, which is 201, is having some value. Okay, so D200 is carrying some value and D201 is having some value. If our source value is within this range, then it will return 1, else it will be 0. Like that, you have 16 comparators here. See, from B to B plus 30. For example, if you are taking B as 200, D200, then it will be 230, D230 and D231. Okay, so if that is within the range, our source data is within this range, then it will returns 1 or 0. So this is the 16-bit result. Okay, so let's see this. Look, here the values are given in hexadecimal. Okay, so see here they are having some value in D100, that is the source data. So this is our source data. 03A0 is the source data, and D200 is the block. So in this block we are going to split that into 16. Okay, look at this, D200, D201. So we have to check whether this 03A0 is in the range of the value which is in D200 and the value which is in D201. Okay, so there may be some application like this complete D200 from D231 is having some values, and you want to compare or you want to find out whether the particular source data is in the range of any one of these blocks. So in that case you can make use of this block. Look at this, 03A0. So it's not in this range. Okay, so it is returning 0. For example, see, look at this, the third bit is having 1. That means what? This 03A0 is in the range of 0000 to 0400. That's what it is returning 1. And look here also, it's also same 03A0 and 0400. It is within the range. The number is starting with this number itself. So it is returning 1. So now we'll see one example in the PLC program. Okay. So before that, this block works with the hexadecimal values. So I have put some hexadecimal values here. For example, if I put 64 and the decimal value is 100. If it is 96, it will be 150. Okay. So just these value is for our reference, which we can make use of it in the example. So let's see that. Now I'm going to get this instruction first. Compare BCMP, this one, unsigned block compare. So go with this. It's asking for the address. So I'm going to give the same address what we have seen in the manual. D100 is the source, D200 is the first block of the address, and this is the result data. That's it. So we have added that. Okay. So now add one input condition 0.00 and connect this. It's connected. All right. So now let's take the monitor window. It's not output. It's a watch window. Okay. So I'm going to add this address D100. This is D200. This is D300. Okay. So now let's go for the simulation. See, here you can see. Now just I am giving some value. Okay. So let's take the example of this one. Let's give the value 100. Understand? Let's give the value 100. So it will be taking that as 64. So I'm giving the source. See, I'm in source data I'm giving that as 100. If you give us a decimal, it will take as a hexa. Okay, 64 is taken by D100. Now give some value for D200. So what I'm going to give? I'm going to give D200 as 50. Okay. So for 50 it is 32. So now what it will be doing? It will be first comparing D200 and D201. So now in our program we don't define any value in D201. Okay. So now we have just put the value in D200. So we'll do one thing. We'll put some value in D201 also. So what I'll do, I'll take one addition instruction. I am giving the values D201, okay, and D202 and D203. It will be storing in that result, okay. So now that's it. Addition is just addition, so that we can move the value. That's what I have taken the addition instruction. To move the value, I have used this. So now watch clearly. Now our source data is having the value of 100 and D200 is having 50. Now what I'll do, D201 I'm having that is 150. Okay, I'm giving the value as 150. And this one, D202, I'm giving that as 180. Let it be as 180. Alright. So once I will turn on, what will happen? These two will get addition and here we will get the result. In the meantime, what this block compare will do? First thing, let's see this. We are having 100 here, okay. So D200 is having 150, I think. I have given 150. D200 is having 50. D201 is having 150. See, this is 50, this is 150. So our 100 is within the range of 50 and 150, correct? So it will return 1 here, right? Now what value I have given to 202? So for 202 I have given 180. Okay. What will be in 203? 150 plus 180 is 200. It's 210. No, not 200, 230, and it will be 330, right? So is that 100 is in the range of 180 and 230? No, right? So it will be returning 0. So let's watch that. I'm going to force this. Yeah. So look at this. This is the answer which is having 1 here. That means what? This 100 is within the range of 50 and 150. So every 16 bit it will compare. So 201, 200. If it is in range, it will return 1. Else it will be written 0. Like that we have this answer. Alright. So I'll do one more thing. Now let's move some value for 204. Okay. So what I'll do, I'll take the same bit and I'll do the subtraction of this minus D203 D204 D205. So now D203 is having some 230 value, I'm right. I'm going to minus the 230 minus some 200, like that will do. $180 will minus. I'm turning on this. So now it is 150. So 100 is within the range of 203 and 180. 203. Okay, let's compare 202 and 203. What is in 202? What is in 202? It is 180. Okay. So 180, 330. Is that 180 and 330, 100 is it within the range? No, right? That's what it is returning 0 here. See the second bit. For example, if I change the value of our 100, instead of 100, I'll give 190 and see this bit is on. Can you able to see? This bit is on. That means what? This 190 is within the range of 180 and 330. That's what this bit is on. So like that it will compare each and every two 16-bit register. Here it will compare this value between this value and this value. If it is present, if the source data is present, it will return 0. Like that it will compare and it will give the 16-bit answer. So it will be starting like this is the least significant bit. This is 16th bit. The last one is the 16th bit. So if you see, this is the 16th bit, which is 0. Okay. So like that you can compare. Now I can make this to some other value. Let's see. Now I am giving the value of 240. So 240 is within the range of 200 to 300. That's what this is on. What value we have given in 200? It is 50, right? So 50 to 200 and 201. So this is 50, this is 150. Our value is this is 200, right? Yeah. Okay, this is 200. So 50 to 150 it is not. So this is 0. So the 200 take 200. This is between 180 and 330. That's what this is on. Okay. So now change the value of the third one also will change. Now 200 we have given, no. So we will checking this value to 200. So 330, 200. So we have to check whether the value which is in source is between these two values. If it is there, it will be turning on. Okay. So the one thing what we have to understand is the value, the address what we have given here, that will be the first 16-bit register. So 200, 201. Okay. Next 202, 203. Then 204, 205. Between 300, this one. 330, yeah, this one here it is 204, no. So this is 200, this is plus 130. If it is not in the range, it will return 0, else it will give some value. So like that you can compare the block and get the result in the new register. So all 16 comparison are done and put the result like this. See, all 16 are done and the result is displayed in the result register. So this is block compare. So once you practice the example, you can understand it in a better way. So here the values are shown as the hexa. Okay. So now we'll give the value as 10. Okay, I'm giving 10. And 200 will be 5. Let's see, 203, 201. So 200 and 201 will get compared, no? So this value is 10. Okay, 200 is 5. So I'm giving this as 15. Look what is happening. Nothing is happening because the condition is false. I am making the condition to true so that the first bit gets on. Because 5 is in the range of 10 is in the range of 5 to 15. Understand? So now what I'll do, Now the next comparison will be between 202 and 203. So 5 is in the range of 180 and 195? No, right? That's what it is, 0. Now I will change the value of 202 to 3. Now see, 3. 5 is in the range of 3 to 18, am I right? That's what the second bit is on. Okay, so this is block compare. So for getting those values, I am using plus and minus block to feed this value. Okay, since we have not seen the move instruction, I cannot use the move instruction here. In the later classes, we will see that instruction. So I have taken the help from addition block to see the value of this. Okay, 204, 203. The thing is, first what we have to compare, 200 to 101, then 202, 203, one by one, 2 registers at a time, from 200 to 231. So there are 16 in this line and 16 in this line. So we will be getting the result in another 16 bit. So I hope you have understand this block compare instruction. Just practice it in a software for understanding the instruction well. So thank you so much. Kindly like and subscribe our channel for more videos. Thank you.